If there's anywhere in the country where you should care about your air conditioning system, anywhere in the South is going to be it. And Charleston is no exception with our hops, hummers, our super high humidity. I mean, honestly, it can be kind of brutal sometimes. But in today's video, we're going to talk about everything you need to know and probably stuff you didn't even want to know about the HVAC system. Now, the HVAC system, or also known as your air conditioning system, is the third and final part of the mechanicals of your home. The first two parts being the electrical system and the plumbing system. And this is also part number 6 of my 9-part home systems explainer series. Now, fair warning, in order to fully understand how the HVAC system works, I'm going to talk a little bit about basic heat transfer principles and how refrigeration works in general. If that's a little too much for you, feel free to skip ahead just to the major components, replacement costs, things to look out for, things along those lines. But for those of you who, like me, have the engineering mindset and like to nerd out about how home systems work, then this video could be pretty productive. So let's go ahead and jump right into the HVAC system. Before we get started talking about all the components of the HVAC system, let's talk about what HVAC actually stands for. So HVAC, heating, ventilation, air conditioning. So these are the 3 to 4 major components and functions of your HVAC system. The heating keeps you warm in the winter, the cooling keeps you cool in the very hot summer, and the ventilation keeps all that air circulating in the house to make sure the air stays fresh and conditioned for you. Now, before we get started, this next section, fair warning, this is a nerd alert. We're going to dive into heat transfer principles and how refrigeration actually works. I did spend 11 years in the Navy doing all sorts of engineering stuff, electricity and HVAC and that type of thing. So I'm going to try to keep this as simple as possible. But if you get lost, just send me a message or drop a comment and I'd be happy to explain more in person. Principle number 1 about air conditioning is it's all about heat. Heat and heat energy are the only things we can really move around. So cold or coolness is really just the absence of heat. So anytime we're talking about air conditioning, heating, ventilation, really what we're talking about is the transfer of heat from a hot location to a cold location. And the best way to transfer heat is by getting a hot substance and a cold substance right next to each other, and by circulating either air or fluid of some kind to allow that heat transfer to continue on an ongoing basis. The key to any good refrigeration cycle, which is the process by which we cool an area down, is to have flow. And there, in the refrigeration cycle, we have 3 different heat transfer flow cycles. So I'm going to apply this to the house and the home because it's easier to understand than if I start diving into like commercial HVAC units. So in your house, there are 3 different heat exchange cycles that are going on anytime your air conditioner is running. All 3 of these heat exchange cycles are based off of your air conditioning system having a fluid called refrigerant that's circulating inside of it. Now, refrigerant is just a fluid that has an extremely low boiling point and is very good at absorbing and releasing heat. So the first cycle of heat exchange is inside your home itself. So think about it. When you turn on the air conditioner, you have the cold air that's coming out of your vents, and then that air heats up as it's in the room, and then it gets to be hot air, and then that air returns back into your return register. And that cycle just keeps going over and over and over again. So you got the cold air out of the vent, warm air in the room, back into the return register where it gets cold again, and it goes around and around and around. So that is cycle number 1. Cycle number 2 is actually outside the home. In cycle number 2, the hot refrigerant, which is inside your air conditioning system, releases its heat to the relatively cooler outside air. So we have the hot refrigerant, which then releases its heat to the outside air, and then that gets circled back to the AC system where it gets heated up again and then cooled down. So that's our second heat transfer cycle. First heat transfer cycle is inside the house, cold air out the vents, hot air back in, cold air out the vents, hot air back in. The second heat transfer cycle is outside, hot refrigerant releasing its heat into the cold Charleston air and then recycling back there. Now the third cycle is in the air conditioning system itself. And this is all based around the refrigerant that I mentioned earlier that has a very low boiling point. And the refrigerant in this third heat transfer cycle is what really ties the whole system together and makes it work to keep your home totally breathable and livable in the heat of the Charleston summer. This third heat transfer cycle is where the cold refrigerant that is returning from the outside of the house meets the warm air that's returning from the inside of the house, receives the heat from the warm air in the house, and then takes that heat and puts it back out to the exterior of the home. So that completes the third cycle of our heat transfer. And if you link them all together, what it results in is that the warm air in your home gets the heat pulled out of it, and that heat is transferred outside the home. So you get warm air in the home that gets pulled back into the air return. Then that hot air puts its heat into the refrigerant, which now gets warm. That refrigerant puts its heat in the outdoor areas. So now the refrigerant is cold again. Then we take that cold refrigerant, push it back into the house, where now we can use that cold refrigerant to make the air cold that then gets pushed back out into the house. Now, I know this is a pretty simple explanation. Well, these are very complicated heat transfer topics that have been simplified a little bit, hopefully in a clear manner. But in general, that's what we're working with. And the thing that drives this whole cycle is flow. Whether it's flow of refrigerant, flow of air, it's all centered around flow and heat transfer. Woo! So now that we have a basic understanding of kind of what the heat transfer cycle is, we can use that heat transfer cycle to identify all the different parts of the air conditioning system in our home. So the first part of the HVAC system is how we actually move the air in the house. And this is done by the first major component, which is the air handler. Now, the air handler has a big blower in it, and it has the condensing coil, which is what helps make the hot air that's returning from the rooms in your house get turned into cold air. The air handler is what does all that work. So it's going to pull the air with a big fan through the return register in your house, make the air cold with the refrigerant, and then push that air back out through the ductwork into the rest of the home. So first major component, air handler. Usually the air handler is located in the attic, if you have an attic, or maybe it's in a closet somewhere in a smaller home. I've seen it in either one of these locations. Although I have to say, in the attic is probably the most common area. The second major component of our air conditioning system is a combination of the compressor and condenser. So this is the part of the system that is outside the house, and it's that gray block that's usually hidden behind the house or in a side yard that has the fan that's on the inside of it. And what that component does is it takes the heat that the air handler has pulled out of the air of the house and is put in the refrigerant, and it allows the refrigerant to release all that heat to the exterior air. And the way it does that is by having a fan that runs to allow the refrigerant to expand and release its heat to the exterior of the home. So those are the first two components of the HVAC system. The air handler is going to actually move the air throughout the house and transfer the heat from the interior of the house into the refrigerant. And then the compressor condenser unit, which is outside the home, takes the heat from the refrigerant, releases it to the atmosphere, and allows the refrigerant to get cold again to then cool off the air in your home. Now that we have to have a way to get that nice chilly air that the air handler has made out into the different rooms and areas in your home. And thus we have the third major component of your HVAC system, which is the ductwork. Now, the ductwork can run usually through the attic, sometimes through the crawl space if your home does have a crawl space. And depending on the age of the home or the aesthetic that you're going for, sometimes historic homes that have been converted even have exposed ductwork that's up kind of in a corner of the room. And some people like this kind of look. It's kind of industrial feel. Personally, I'm not a fan of it, but I digress. So the ductwork is one of the major components of your HVAC system, and a lot of people don't think of it as such, but the ductwork is one of the more important components. Because if you don't have the ductwork, then you don't have any way to direct that nice chilly air from the air handler into all the spaces in your home. So if you don't have the ductwork, you're not going to have a cool home. You might have a cool attic, but not a cool home. Those are the three major components of your HVAC system. So you have the air handler, the ductwork, and the compressor and condenser unit. Now, all these things are great, but they don't function without a control system, which is where your thermostat comes in. And I'll give a special mention to your air filter here, because this is also a super important part of your system that can cause your system to fail prematurely. So we're going to come back to that in a second. The thermostat, pretty straightforward. It's that little box on your wall. You can use it to set the temperature, to control the unit, whether you want it to be on heat mode, cool mode, just run the fan, whatever it may be. And this is what's really going to allow the system to function properly. So the thermostat senses the air temperature in the home, and once it reaches a set point, it's going to kick the unit on to start that refrigeration cycle, which is going to start pumping cold air throughout the house until the temperature comes down to the set point, at which point the thermostat will sense that temperature again and tell the unit to turn off. Now, I did mention the air filter. Holy cow, air filters. Probably one of the easiest ways that you as a homeowner can extend the life of your system and make sure the unit is functioning properly. The air filter is going to filter the air that's returning from the house and going into the air handler. Now, the issue is that if you allow that air filter to become super dirty and super clogged, it blocks the airflow. So effectively, it's like putting a blanket over the part of the air handler that's pulling air from the house and trying to cool it off. So the net effect of this, if you have a super dirty air filter, is that you're going to choke out your AC system. You're going to minimize your airflow. The air is not going to be very cool because there's not going to be very much airflow moving through the system at all. And you're going to cause your unit to work super, super hard. So far, we've talked about the air conditioning side of your HVAC system, but we haven't yet talked about the H, which is the heating portion. There's a couple different ways that you can find a heating system in a home. If you're in the Charleston area and you have a central heating and air system like most homes do, the heating component is going to be a heat pump, which is built into the air handler. Effectively, this is going to have some heating units inside the air handler that when the fan turns on, it's going to circulate air. But instead of taking hot air from the house and making it cool using the refrigerant, it's going to take cold air from the inside of the house and heat it up using those heating elements in the ductwork, and then send that hot air out into the different rooms. Now, in some older homes, like historic homes, you may have radiators, which use either water or some type of oil to heat up the radiator that's in the corner of the room, which then radiates heat, hence the name, out into the room. Or some homes that were built in the 50s to the 80s may have baseboard heaters, which are just electric heaters that either plug into the wall or have a separate power supply. Now, those baseboard heaters can be super expensive to operate because it's just a giant electrical heater that's used to heat up the rooms. This would be kind of like having your stove on just all the time, right? It's going to pull a lot of power because it's designed to pull power and make thermal energy or heat. Now that we've talked about all the major components of your HVAC system, let's do a quick rundown of how much those components cost and what their lifespan is going to be, as well as ways to identify a problem. Let's start with the problems first. The easiest way to identify a problem with your HVAC system is if your house is unseasonably hot or unseasonably cold. This could indicate a problem with the ductwork. Maybe you're blowing cold air into your attic and the cold air from the air handler isn't making it into the individual rooms. Maybe the air handler is not actually moving air. Maybe it's being choked out by an old air filter that you haven't cleaned recently. Go check your air filters. Or maybe your compressor in the condenser unit outside is damaged in some way. So it's not able to take the heat from the house and release it to the atmosphere. Could be any number of different issues. As far as the costs and the lifespan go, each of those individual components are going to cost about $4,000 to $6,000 to replace. So, for example, if you get all new ductwork, it's going to be around $5,000 to $6,000. A brand new air handler, probably going to be around $4,000 to $6,000. A brand new compressor and condenser unit, going to be around $4,000 to $6,000. So if you get a whole brand new central air system, it's probably going to cost you around $15,000 to $20,000 to get everything all done together. Now, the good news is that each of these components is going to last for around 10 to 15 years if you maintain everything really well. The ductwork is probably going to be good until it starts to rot and decay. So we're talking 15, 20, 25 years, maybe even longer. The air handler and the compressor, those are going to last anywhere from 10 to 15 to 20 years, depending on how well you maintain the system and how hot and humid the environment is. In Charleston, our HVAC units have a much shorter lifespan because they're always running. They're running from like March until late October, early November, just because it's so hot here. So it really is going to depend on the climate of where you are and how often you're running your system. As a pro tip, a semi-annual tune-up is usually going to run you maybe $100, $150, but it's going to be worth its weight in gold if it keeps your system running properly and it keeps your system properly maintained, and it's going to really pay off over the long term. Now, all of the things that we've talked about so far are for a central heating and air system, but there is a bonus type of HVAC system that is becoming more and more popular, and these are called mini splits. So mini split, you may have seen them if you stayed at an Airbnb or a home that doesn't have central air conditioning, but it's going to be a unit that is in an individual room that is effectively acts as its own little mini air conditioning system. So usually it'll be like a big white bar that would be, like in that general area, and it's going to be controlled with a remote. Now, the benefits of this, it gives you very accurate control over the temperature in that room, and the cost is much less than a brand new HVAC system. So you can get parts and labor for a mini split to be installed are going to be $4,000 to $5,000 total for the entire system. But again, that's only going to be to service a single room with this mini split system. Now, the downside is if you ever stayed in a room or tried to sleep in a room that has a mini split in it, it can be kind of loud. Maybe like the LED lights on the display are going to be kind of bright. So it can be a bit of a hassle or inconvenience, but they are very effective at maintaining the individual temperature of the room. The other major problem that I see with mini split units, because they have two components, that big bar that's in the room, as well as a fan and a compressor that is outside, is when you drill a hole from the interior of the home to the exterior of the home to run those pipes and the cables to allow that heat exchange to happen, a lot of times that hole is not sealed well by the technician or by whoever is installing the system. And if that's the case, then you're just asking for water intrusion and mold issues if that hole is not sealed well. So as long as you make sure that's going on and you're happy with your mini split system, good on you, and it's going to work great. So that brings us to the conclusion of our HVAC video. I know I started off pretty tech heavy, talking about heat exchange and refrigerant cycles and all that good stuff. I love that type of stuff. I think it's super interesting, but I can understand if it's a little bit too much for some people. In any case, this is part number 6 of my 9-part home series video about all the different components in your home. If you're looking for the other 2 mechanical systems, you can check out a link in the description of this video. And there you'll find the other 2 mechanical systems, which are plumbing and electrical. If you're looking for a general overview, I have a general overview video, again, in this playlist that just covers all the systems in general. And if you're looking for more information on each of these individual components, feel free to drop me a message, a comment, or a DM, and we'll get you all squared away.